Hello and welcome. Today I want to make a little video about demonstrating the curve of the Earth using photographs and perhaps video. Now, here is a photograph of Bass Rock and the island of Fidra in the Firth of Forth. This is Bass Rock, this is Fidra, and the lighthouse on Fidra is visible just here. This is the same, almost identical view, but from a higher elevation of the same location. Slightly more zoomed out, I believe. You have Bass Rock, Fidra, and the lighthouse, and two other islands have popped into existence next door. They were not visible from the lower elevation, even zooming out a little bit. Now, normally people would accept this, or most people would accept this as a demonstration that the Earth is not flat and does indeed curve. The Bass Rock appears much taller, as does Fidra. More land is apparent close together. In the lower elevation, only the top of Bass Rock is seen, only the very top of Fidra is seen, and a horizon line passes above the other two islands. However, both photographs also show a nice example of an inferior mirage or mirroring near the horizon. So from the higher elevation, the mirror line, so-called, appears where the red line is here. And anything between the hard horizon line of the water and the red line here, the mirroring line, is an inverted image of what is directly above the line. That's particularly noticeable in the other image, the one from lower elevation, where we can see the sky reflected, or not reflected, but the sky inverted image showing below the island of Fidra here. Now, this effect is seen quite often, especially over water, and especially when viewing objects that are a long way away or beyond the horizon. And it occurs when the air just above the water is warmer than the air that's a bit higher up. Some people talk about layers of warm and cool air. What's really going on is more likely to be a gradient of warmer air near the surface and cooler air the further up you go. Now, this well understood optical effect has been hijacked by flat earthers. And they're claiming that this can explain why ships and land disappear from the bottom up on a flat Earth. I won't go into details of why they claim this or what they claim is going on, because, well, they don't go into any details about it. They simply make the assertion that because we are seeing something that isn't really there in this location, then it's possible for that to be hiding what should be there, or what actually is there. Of course, it's complete nonsense to claim such a thing, but I'm going to leave explaining exactly why that's complete nonsense for another time, another video, possibly even somebody else to do. But this excuse is currently being used by flat earthers, especially those with their brand new P1000s, as a kind of get out of jail free card, or a fig leaf, if you prefer. Whenever their observations show ships, land, or buildings being obscured by the horizon, they simply claim that what we're seeing is the effect of an inferior mirage. Now, I'm not going to use the images that I've shown you to argue that the Earth is in fact curved. I thought about what flat earthers are doing, and I decided, okay, if that's how you want to play the game, let's take the inferior mirage out of the equation completely. Let's not even look at observations over water. and with all the refraction effects that often occur. What I wanted was an object of known height, significant height, above sea level, and a place to put my camera that was the same height above sea level. And I also wanted something in the distance, for example a hill, that was taller than the height that my camera was at, and also, or the elevation that my camera was at, and also had objects on it, houses, trees, fields, or whatever, that would allow me to identify the height on the distant object. And here's why I want those things. So on a flat Earth, if my camera is located at the top of this red block, and there is another red block some distance away, and I point my camera straight at it, then any subsequent objects that are the same height will appear directly in line with this first object, as indicated by this straight arrow. On a spherical Earth, this does not follow, this does not happen. On a spherical Earth, if we line up the top of this object, or the camera at the top of this object, with the top of a nearby object of the same height, then any other objects similar height or elevation in the distance will be significantly below the line of sight that we have through this top of this object here. Further away that object, the bigger that difference. Now, all I needed to do was to find a location I could place my camera that was the same height as a point on a particular object, and something in the distance that would act as a backdrop that I could measure the height of our line of sight here. Just for clarification, it doesn't matter where you put these blocks on a curved surface, the same thing always applies. If you line up the first two, then the others will always be below that, those two. So I had to set about looking for, I'll just take those pins off for the moment because we don't need them. I had to set about looking for somewhere, and as you might have guessed from the pictures of Fidra and of the Bass Rock, I live fairly near the Firth of Forth. And the Firth of Forth has some bridges across it. The old rail bridge, Victorian structure, cantilever bridge, a suspension road bridge built in the 1960s, and a new crossing called the Queensferry Crossing, which was completed just a year or so ago. Now, these two bridges, the Queensferry Crossing and the Forth Road Bridge, have towers on them that are a known height above the mean level of the water in the estuary here. That's mean sea level to you and me. The road bridge tower height is 156 meters. And I haven't actually got that here, but there is a Bristol engineering site which lists the heights as 150 meters, but it appears to be anomalous, and everywhere else lists them as 156 meters. This Forth Bridges information site clearly states 156 meters high. So I had something 156 meters high here, and all I needed to do was find a hill or location 156 meters high with a clear line of sight to that bridge, and I was 2/3 of the way through my task. This is a location that I have taken photographs from before, although not published on YouTube. there's a little lay-by here and an area of just parkland, effectively. People walk their dogs and so on, just in between these houses, but no house has been built here. And there is a trig point here. Now it turns out that that trig point, which is this one here, if we go to satellite imagery of this, you can see that it's the same location. Not sure if it will let me. Yes, it will let me zoom in further. That's good. So you can see that this is the same location. The pin here is in slightly the wrong place. The trig point is just there, but this is the same location I was talking about, and the trig point height is 157 meters. It's listed as 156.7 meters elsewhere. So 156 to 157 meters for that trig point. So I had the trig point established as where I wanted it, to the height that I wanted it, and I had my object height, my bridge tower height, both at around 156 meters. Now all I needed was something on the opposite shore that I could use, and fortunately near Edinburgh are a range of hills called the Pentland Hills, which kind of start about here and run in this direction. Those hills themselves are around 450 to 550 meters high and slope on down here. So I got my camera out and went off and took a photograph. Now, this particular image has been enhanced somewhat to bring out some of the detail on the sloping land and the Pentland Hills in the background. Now, this is over 400, well over 400, around 500 meters high. The hills and the back here, and one that I think is probably just off screen for you, a peak just off screen for you. But seeing as we only need to come up to something just over 150 meters, this was going to be great. And fortuitously, there is a house here on the opposite side that actually lines up directly with the left-hand part of the north tower here. We know this height is 156 meters, and so if the land just in front of the house here is also at 156 meters, then the earth is flat. And if the land in front of this house here is greater than 156 meters, then we know that the earth is most definitely not flat and most probably is a spherical shape, because that's what all the other evidence indicates. So here is a close-up, just zoomed in on that particular portion of the photograph. And you can see this house here, and I've marked here 185, it should be 183 meters or thereabouts, and 175 meters. Now I'm not sure whether the 56 meter height for the tower, 156 meter height for the tower, sorry, is given for this light which is on the top of the tower, or for where the solid portion of the tower actually ends. But we can be confident that it's somewhere in that range, either here or here. Now, going back to Google Earth, if we look at the elevation profile, that's not what I meant to do. The elevation profile from our camera location here on the left, through over Dunfermline and past Rosyth and Pitreavie, down to the estuary here, which is indicated as a flat line on the profile, and then up over the land at just south of Queensferry and past Edinburgh Airport, which is located just here. The land then starts to slope up and reaches 150 metres at about this location, which is just before we get to the town of Balerno. So I knew that I was looking for my house in the area near to Balerno. Zoom in, and there are fields directly in front of. I'm going to go back to 2009 imagery because it's a little clearer. There are fields here in front of the house in three fields before you get to the railway line that runs along here, and then another field. The land dips down here, is much lower down here around the railway line, as you might anticipate, and slopes up this direction. And so I was pretty sure, having drawn a straight line of sight from my camera through the tower, that this was the house in question. If we go back to the image here, we can see two identical houses, or apparently identical houses, with a third house in between. There's a tree blocking our view of part of that house, but it looks a slightly different layout to these two. Going back onto Google Earth, and we can see this little cul-de-sac is actually built relatively recently. It's not in images prior to 2009. And you can see that there are two houses of identical layout here with another house in between. We don't have a tree here, but it might be a tree from this side of the field, or a tree that's grown up subsequently. That was 10 years ago now that was taken. If you move on to more current imagery, it's difficult to see a tree here, but there may be something else in that area. Maybe something's been built there that obscures the site, and that's 2016. But anyway, I'm happy that these are the two houses, identical houses. There's a third house in between. So the question becomes, what elevation are these properties at? And using the elevation tool on Google Earth, we see that 183 meters just in the back garden of this house. At the top of the field, still at 182 meters, so the garden of the house is barely sloping at all. This field slopes downwards and gets to an elevation of about 167 meters at this end. So that's 14-meter drop from the top to the bottom of the field. The next field slopes more steeply, 165 meters down to 142 meters. So more like 23 meters as opposed to 14 meters. So about twice the slope. And then this field here is not going to be visible from our location because there are trees and other things in the way, particularly this row of trees at the golf course here, which are up at 100, the golf course itself 123 meters, and these trees are obviously taller than that. And this field here is well, it's indicating about 133 meters, but you can imagine that the trees are going to be tall enough, 30 feet high, to obscure that from our view. So let's go back to our image, and I'll just click on to the next one, I think, because it'll be a little bit clearer. No, I have to go back one. The house is here. The first field in front of the house, the one that slopes down about 14 meters, would appear to be in this area here. And I've confirmed that myself. There are other houses here that confirm that, and the row of trees, quite sparse row of trees with some gaps along the near edge of that field, further confirm that what we're looking at here is the top of the the bottom of that first field, and it extends back up here to the road along which the house is pretty much constructed. And so this is the second field, the more steeply sloping one, and the one that we would expect to see above the height of the trees. And then we have third field, which we can barely make out, and there's actually other fields in behind here, which is the trees of the golf course, and so on, before we get to much nearer stuff here. So we've identified that this is the field, the second field down from the house, and this is the first field down from the house. And so when we look on Google Earth, we find that our elevations are, if I can get the correct spot, here is the first field starting at around 180 meters, and the top of our tower aligns with an area towards the top portion of this field. So I've marked 183 meters, 175 meters, and you have to go all the way back down the slope here. I think you can almost make out that that's a slope from the slight shadow there, to get to a point where it's 156 meters. In fact, that's, yes, 156 meters just there. So our image, our photograph, has 185, I've put 183 is more accurate, 175 possibly where the tower is here, about halfway down that field, or a distance down that field. But 156 meters is down here. Clearly the top of our tower is not lining up with 156 meters. Far from it. It's some 20 to 30 meters further up. And this can be further confirmed by looking at a topographical map. Here is the house in question, and the first field here has an elevation of a contour line of 180 meters running along here in front of the house, and so that's the area that the tower is lining up with, just in front of the house there, around 180 meters. And you have to go all the way down to the second field and part way down the second field to get to 156 meters. This is not on web browser. If you click on it in the web browser, you can find the elevation. Unfortunately, it's given in feet. 514 feet is roughly 156, 157 meters, something like that. So this elevations are confirmed in multiple ways. Now, I can anticipate some flat earthers jumping straight to a curvature calculator in an effort to show that this is incorrect. The distance in kilometers from the camera to the house is 22.6 kilometers. It's about 14 miles. Our viewer height in meters, I actually put it in feet here and just converted it to metric, but 156.6 is what we're given. And this gives a drop height of 40 meters. Hidden none, and that was what we'd expect. I'm not particularly interested in the refracted drop height, but it's maybe 34 meters, but let's work with a 40 meter drop height. And I can imagine flat earthers saying, well, why haven't you seen a 40 meter drop when you've looked at this. Why is this only a 30-meter difference in height rather than a 40-meter, which the curvature calculators predict? Well, this would, if someone did say that, it would be a misunderstanding of how the curvature calculators work and what a drop height is. So I've drawn this out here with 3 equally sized blocks around a curve. The drop is given by a level line drawn, effectively a tangent to the curve, drawn out this way. And the drop is the distance from the top of this object to that tangent line. But we're not looking along a line going straight out level in front of us. We are looking along a line between our camera location and the top of the tower of the bridge, which is the same elevation as our camera. Therefore, the effective drop height is much lower than the drop height given by the curvature calculator. And this is therefore in very good agreement with the curvature calculator. The curvature calculator said 40 meters, and the observed drop height is something between 25 and 30 meters, or appears to be something between 25 and 30 meters. And that would make sense if given this diagram. Don't worry about that. I attempted to draw a scale diagram and it confirms the same thing, but it doesn't really work. It's too small to see clearly. So this observation is impossible if the Earth is flat. I've repeated the observation on several different days at several different times, varying levels of visibility. I can usually still make out this house. And the top of the tower always aligns with the base of this house. There doesn't seem to be any refraction effect, certainly on the days that I have made this observation. So the top of the tower is always much higher than it should be if the Earth was flat. And the only conclusion that you can draw from this is that the Earth is most definitely not flat. We also know that the amount by which this tower is above its own height of 156 meters is consistent with the Earth being a sphere of 6,371 kilometers radius. So I challenge any flat earther to come up with an alternative explanation for my observation that would work on a flat Earth. I also challenge them to come to this location and to make the observation themselves and confirm that it is indeed true. Just to finish off, I'll play this little bit of video which just confirms the observation position. This is the house here. It's very hazy in this particular video. This is the identical house and the space in between them, and you can see the top of the tower here just next to the house. The field is down here. But it's going to zoom back out and pan round to the trig point. A confirmation of the camera location for the previous video. So here it is. I'll switch that sound off. That was from an earlier effort at recording this. This is the new Queensferry Crossing Bridge. And here is the concrete trig point. The base of that trig point is slightly above my feet. My camera was positioned at the same height as the trig point here. There is a benchmark at the side of the trig point, which may be the actual 156 and a bit meters, might be at that point. So I may be slightly above 156 or 157 meters. Of course, this means I'm looking very, very slightly downwards towards the tower of the bridge, and therefore I should be lining up on the opposite bank with something even lower than 156 meters rather than something that is 156 meters. And in fact, we line up with 180 meters. So any discrepancy here between the camera height and the actual trig point height is actually in the flat Earth's favor, not the spherical Earth's favor. So once again, if you enjoyed this or are interested in seeing any more videos, please subscribe and maybe even click the notification bell. And hopefully I'll be back again soon with some more videos. I've got lots in preparation and need to get some of them actually finished. Thanks for watching.